Hi everyone, welcome to Physics Live with Angan Bhattacharya once again, and you are well aware to the fact that it is the nanomaterial lecture series where I have decided to discuss the topics of nanomaterials and applications which is belonging to your DSE paper, that is the disciplinary subject paper of course number 3 of UG. Okay. So in the last lecture, I have discussed the introduction about the nanotechnology and why it become very important in the present context or present situation. It has all been discussed in the previous lecture, and it was no one but Richard P. Feynman, who have decided or who have first assumed that we can construct these type of materials. And in the year of 1959 at the Physical Society of America, he has put some questions in the stages that why cannot we manipulate materials atom by atom, why cannot we control the synthesis of individual molecules, why we cannot write all the human knowledge on the head of a pin, and why cannot build machines to accomplish these things. So to answer these type of questions, the first scientist Norio Taniguchi was a Japanese scientist in the year of 1974 first coined the term nanotechnology, where he has give the definition of nanotechnology as the nanotechnology mainly consists of the processing of separation, consolidation and the deformation of the system by one atom or by one molecule. Okay, and these were the things that we have discussed in our previous lecture. Now it is the time to discuss the synthesis of the nanomaterials, as because as we are not known, as soon as we not know the synthesis of the nanomaterials, we cannot analyze them, and the journey to discuss it in our present applications will be no longer contextable. Okay, so it is the first thing or first stage to discuss the synthesis of the nanomaterials. So I have decided to discuss the synthesis of nanomaterials in our present discussion. So without wasting any time, I will go to show you that how can we prepare the nanomaterials or nano specimens with the help of some beautiful techniques. Now many scientists and many researchers have developed many kind of treatments to develop the nanomaterials and nanomaterials and the materials that can be determined by these by the bulk material. Either it may be from the bulk material by the deformation to the smaller parts, or by the accumulation of smaller atoms and molecules to make as clusters and then to convert it as a nanomaterials. Okay, so there are two basic approaches. One is to deform the bulk material. Let me draw this. So one is to deform the bulk material into some smaller clusters, okay, smaller particles, or it may be called the powder. This is the bulk material, the powder, and from this powder nanomaterials are formed. Either it can be formed by this type of approach, or it may be formed, let me draw in it blue, some, these are some atoms. These atoms get accumulated to make such clusters. Suppose these are atoms, these are clusters, and from this, by the accumulation of these clusters, nanomaterials can be formed. So you can see here that there are two basic approaches, either by deformation of bulk materials or by the accumulation of some smaller particles. So these two approaches are namely known as, this is known as the top down approach, and this is known as the um, okay, let me draw it, bottom up approach. Bottom up approach. So there are two types of basic approach that we usually use to synthesize the nanomaterials. Now which one is effective, I will say, or I will discuss in detail after few times. So the name of today's topic, I have to write it in the above. So synthesis of nanomaterial or nanomaterial synthesis. Nanomaterial synthesis. Okay. Now these are the two approaches. Now we can use these approaches via three types of uh, synthesis procedures. The first one is physical process, second one is chemical process, third one is biological process. The three basic science. Okay, biological process. So these two types of classification or two types of approach can be obtained via three methods, either physical methods or chemical methods or biological methods. Now you have to know that out of these, the chemical method is more suitable for the synthesis of the nanomaterials at a very large scale, so that we can prepare a huge number of nanomaterials at a single time with the help of these chemical methods. But it should be kept in your mind that by the chemical procedures or chemical methods, some kind of byproducts are generated in the system which are not desirable in the synthesis of the nanomaterials. And the important fact is that here the byproducts are very much hazardous to our environment. So we should have to find out another approach or another method which is environment friendly. Now the physical method employs a very huge amount of temperature. It should be known to you that the temperature used in this procedure is greater than 350 degrees centigrade, which is very much high temperature. But to perform these type of methods, we have to use this temperature in our experimental setup. And the last one is known as the biological method, which is very much suitable for our production of the nanomaterials, as because biological method employs some byproducts which are not hazardous to our environment and which uses the components of the biological system such as plants, animals, etc. This can employ the plant extracts, certain kind of microorganisms, algae, etc. And this is very much important in our present day because it helps to uh, manufacture the artificial DNA. So this is very much important in our present day. So we should put a star mark in it. Okay, let us move on to our step-by-step discussion of nanomaterial synthesis. So I have classified the um, methods or basic approach in two sections: top down, bottom, and bottom up. These are two approach, and the methods are classified as let me write over here. So the methods of preparation are classified in three stages. Methods are classified into the three stages: physical method, chemical method, and biological methods. Okay, So out of which here I am going to show you some of the methods or some of the procedures involving this type of methods. Let us discuss point by point. At first I want to show you some physical methods or some procedures which can use the basic physical methods. The first one is arc discharge method. Arc discharge method. Okay, arc discharge method. The next one is electron beam lithography or so called the lithographic technique. I want to write it here that lithography. Lithography. What is lithography? All the things will be discussed soon later. At first I want to give up some concept map in this section. The next thing is that ion implantation fall under this category. Ion implantation. Ion implantation. Uh, the next thing is that inert gas condensation. Inert gas condensation. Mechanical grinding. It is very much important in this procedure. Okay, mechanical grinding. Mechanical grinding. Vapor phase synthesis. Vapor phase synthesis. So vapor phase synthesis. These are some of the procedures involving the physical method or which use the basic approach of physical method. Let me give a partition here, and the next point is that out of chemical methods, uh, co-precipitation method, co-precipitation method, sol gel method, hydrothermal synthesis method, electrodeposition method, solvochemical and solvothermal synthesis. Okay, here I put this term here, solvothermal and solvochemical chemical synthesis. Okay, so these are some procedures involving the chemical methods. Again, I am going to give a partition here, and the last and final one which involves some biological method. As I have already said to you that these involve some use of plant and their extracts. Okay, the next thing is that using some microorganisms, such as fungi, algae, bacteria, etc., and algae. Okay, and it also uses some industrial and agricultural waste, using industrial and agricultural waste. Okay, these involve some biological method. At first, I have to discuss what are these two basic types of approach, that is top down and bottom up technology. So, I must not give you the definition of the nanomaterial synthesis. So, at first you should understand the definition of nanomaterial synthesis, which involves nothing but the synthesis is the process. You have to write it here. This is for your exam purpose, okay? The understanding I have already given to you, but this is only for your examination purpose. So you can make some notes by seeing this video, so that the notes will also be prepared along with understanding. Synthesis is the procedure of production of a substance by union of chemical elements groups or simpler compound or by degradation of a complex compound. Okay, here I have used a style of giving the definition of synthesis of nanotechnology. You have to understand the style. Here, the sentence involves two parts. The first one is the synthesis is the process of production of substance. Let me highlight the thing which I want to show you. The production of a substance by union of chemical elements groups or simpler compound. This involves the bottom up technology or bottom up approach, and the last line or by degradation of complex compound. This involves the top down approach. So the definition of synthesis of the nanomaterials is given by using both kind of approach. So it is the important thing to know it here, that the synthesis, when you are asked to write what is nanosynthesis or nanomaterial synthesis, you have to write the accumulation of top down and bottom up approach. Now, top down technique. It was the first procedure or first approach to synthesis the nanomaterials. It involves nothing but the degradation of some bulk materials, which is very much easy when we apply or when we employ some steps regarding it. So it was the first observation and first technique to synthesize the nanomaterials in our experimental purpose. Okay, so conversely, the bottom up is absolutely opposite to the top down technique. Here the simpler compounds can be formed by the union of some smaller compartments such as atoms, molecules. These are accumulated to make some clusters, and from these clusters the nanomaterials gets formed. Okay, so the top down technique employs the degradation of bulk materials, and it is helpful for the integrated circuit fabrication as well as the nano electromechanical system, in short, which is known as the names. Okay, so these two can be prepared effectively by the top down techniques, and the basic principle of this approach that I have already told you that is to break the large grain sizes bulk materials into the smaller one by the use of physical process like the grinding, mixing and milling, etc., crushing. But the limitation employs here limitation is that it does not produce, or it cannot be able to produce uniformly shaped material. So uniformly shaped materials cannot be produced with the help of this technique. This cannot be produced with the help of top down technique. This is a limitation or problem employing the top down approach. But the biggest method is the imperfection. Biggest problem, big problem is the imperfection of surface structure of prepared sample. As because I will discuss after some lectures in application of the nanomaterials, what you can see that the surface plays a dominating role in case of the nanomaterials. The surface to volume ratio plays the important role to use the nanomaterials in our present discussion, as because it implies large surface area than the bulk materials, so it may have some exciting properties which we can use in our modern applications. So it will be discussed in the latter, but the main thing is that in the top down techniques the surface morphology is not uniform and also surface defects are present, which makes the process not useful always. So that we have to find out some another method or another approach for synthesis of nanomaterials. Now the top down technique employs the process such as mechanical grinding, metal vapor, thermal breakdown, chemical breakdown, spontaneous chemisorption. These are some various processes employing the top down approach. Spontaneous absorption, chemisorption. Okay, so these are some procedures employing the top down approach. Okay, now since here some limitations are present, so we have to find out some another approach, and the scientists were very much eager to know or to find out the another approach, and it was Eric Dexler, who in the year of 1987 in his book Engines of Creation first give the idea first give the idea about the bottom up approach. Okay, this bottom up approach was think to be from nature. How? As because we know that in our nature the smallest component of living organisms is cell, and by the accumulation of this cell the tissues are formed, and by the accumulation of these tissues some organs gets formed. Okay, so this is some step by step accumulation of smaller components to make such bigger things. So the bottom up approach employs the smaller components, that is the building blocks of atoms, which is known to be the atom. The building blocks of materials such as atoms which gets accumulated to make some bigger thing that atoms but smaller than our uh, material nanomaterial to observe, such as clusters. These clusters gets accumulated further and generates the nanomaterials. Okay, so this is the main thing in the bottom up approach. Some techniques are also, scientists are very much eager to find out some techniques where the auto accumulation of the materials, sorry, the auto accumulation of the materials, the auto accumulation of the materials gets formed, which is known as to be the self, uh, what the thing is happening here. Okay, the auto, what I am saying, sorry. So the self creation of the nanomaterials are very much desirable to our present day. So the most of the scientists are finding out the way to form the self assembly nanoparticles, where in which the desired nanostructure gets self assembled without any external manipulation. Okay, so here, sorry, so here the object size is getting smaller in nano, when the main uh, advantage of using this bottom up approach is that by the top down approach, when the particle size gets smaller than the nano dimension, particle size gets smaller than nano dimension or our desired dimension, it can form in most of the cases that the by breaking down the bulk materials, it has breaked up in so small that we cannot use them in our practical purpose. So we have to use then the bottom up approach, where these small clusters can be employed to make the nanomaterials or certain kind of desirable dimensions. So bottom up approach is important here, and the fact is that we can size up our most of the desirable dimension by the help of bottom up approach, as because it employs some accumulation of smaller compartments. So our desired dimension can be easily formed by the bottom up approach, which cannot be done by the top down techniques. So this is some another kind of uh, advantage over the top down technique. Okay, so let us discuss the, okay, before discussing the difference between top down and bottom up approach, let us find out what are the methods or what are the process employing the bottom up approach. So the processes are, first one is sol gel method. Second one is chemical reduction of salt, chemical reduction of salt, solvothermal processing, precipitation, microemulsion, electrochemistry. Okay, all the things fall under this category, but it is very difficult to discuss all the synthesis procedure with you at in the very short time here. So I have decided, or the syllabus has decided, that we have to only know about the important procedures which are very much helpful over the others to discuss in the case of the synthesis of the nanomaterial. So the syllabus is set up in such a way that the methods which is given to your syllabus are the most advantageous as compared to the other which are not given to your syllabus. Okay, but the thing is that syllabus has given some procedures, but each procedures have their own limitation and usefulness. So we have to read out, or we have to understand all the methods with, along with uh, the specific advantage and limitation of them separately. So without wasting any time, I want to give you, or I want to share you the difference between the top down and bottom up, and then we will move out to our process involving the synthesis. So it will be a very interesting lecture, and this lecture is the basic lecture of the all kinds of lectures that I have decided to give you in the succeeding days. So this is a building block of all the succeeding lectures which I will giving you in later time. Okay, so this is very much crucial and important. You have to understand it very carefully. So I have already told you some limitations regarding the top-down technique which can be balanced by the bottom-up approach. And the last one topic which I think is missed out here, that the bottom-up approach are newer, and so it is expected to be an alternative for the top-down technology. And the bottom-up approach can produce structures with perfect surface and edges which cannot be produced by the top-down approach, as I have already told you. And the thing is that in the top-down techniques, as because some breakage of the bulk materials happening, so some byproducts get generated which may be hazardous to our environment. Also, by the breaking down, certain kinds of vacancies are created inside the atoms or inside the desired materials. So the surface gets defected, and it may be known to be the surface defect, um as well as some imperfection or impurity gets there is a possibility to get the impurities is present in the vacant species. So it is not the pure process to obtain the pure nanomaterials, but by the stepwise accumulation we can find out in the nanotechnology by the bottom up approach. So it is the best process, and it is very much important process over the top down technique. Okay, so these are some difference and these are some advantage over the bottom up to the top down technique. Now it is the time to discuss the synthesis process which are given to our syllabus and which are very much important over the other which is not given to our syllabus. But this process involves some its own limitations and usefulness. The first process is photolithography. Photolithography. So, what is this photolithography? At first, you have to know that this is a approach of top down. So you can understand this is very much old method. Okay. Now, what is the word lithographies mean? Lithography. This is the Greek word lithos, meaning stone, and graphia means to write. So by the accumulation of these two words, lithography generates. So we can say that lithography is nothing but to write over the stone. Now, what is the stone in the process? And what kind of way we can write on the stone? So here silicon wafer acts like a stone, and we have to write some informations or some patterns over its surface so as to make it important or so as to make it useful in our practical applications. Okay, so the way of writing can be classified also in three ways. Either it can employ some optical or UV light radiation, so that the word photolithography stands for it. The next thing is that X-ray lithography is also present, where uh, we can write the desired pattern with the help of some X-rays, where the X-ray beam is used to write over the silicon wafer. And the another lithography process is particle beam lithography, where the electron beam ions are used to modify the material properties. So there are three types of lithographic patterns. The first one is photolithography or light lithography. Photolithography. Next one is X-ray beam lithography, and another one is particle beam lithography. Okay. Okay. Now, what are the steps involved here? So we have to form nanomaterials with the help of photolithography technique, and here the word involves two Greek words which means to write over the stone, as because lithos means stone and graphia means to write. So here the stone, here the silicon wafer plays the role of the stone, and we can write the information or write the desired pattern with the help of photons or UV light or UV radiation with the help of photolithography technique, or it can be written by the X-ray beam, which is known as the X-ray beam lithography, and it can also be written by the electron beam, which is known as the particle beam lithography. But the steps involving here are: first one is the wafer should be cleaned, so wafer cleaning is the first step. The next step is that barrier layer formation, barrier layer formation. The next thing is that photoresist application. Okay, now the question which is coming to your mind: what is photoresist? We cannot know about the photoresist. So you have to know at first what is photoresist. Photoresist are certain chemical organic polymers which changes its structure in the presence of the UV radiation or light radiation. So that the name photo employs here. So photoresist are the chemicals of organic compounds which can change their chemical structure in the presence of UV radiation. So photoresist application is the crucial step involving photolithography. The next thing, and it should also be known to you that the photoresist also classified into two types. I will discuss. So the fourth step is soft baking. This is not hard baking, this is soft baking, okay? And the fifth step is mask alignment. The next step is exposure and development. And the last one is hard baking. Okay, now this is the method. I have told you already that this is a method which involves the top down approach. Okay, so top down approach means the degradation of the bulk material. So we have to degrade the substrate which is used in our methods to produce the desired pattern nanomaterials. So at first the substrate or silicon wafer is taken to our hand. Next it is cleaned in the certain process, chemical process, by the cleaning process, and next the clean wafer is ready for the lithographic technique, and the photoresist is applied over the silicon wafer. I have shaded the photoresist here. Next thing is that the wafer is put into the oven so that it gets soft baked like this one. Okay, the next stage is the wafer is put into the mask aligner. So mask aligner is put here. This is mask aligner, and the next thing is that it is ready for the radiation. exposure to radiation and development. So exposure of radiation taking place like this, and I have already told you mask aligner plays the role where we want to use the photoresist property. Okay, so these regions are blocked by the radiation. These regions, through these regions the light cannot able to pass out, but through the non-shaded region the light can able to pass out. And depending upon the property of react to get reacted by the UV radiation, the photoresist can be classified into two types, positive and negative. Positive photoresist is one in which uh, the resist photoresist which remains soluble, which gets soluble under the action of the, okay, this is block, this, okay, so the picture is opposite. So here this and this, so you can clearly see here that the photoresist which is exposed to the sunlight gets completely soluble, and which gets masked remains in the silicon wafer. So as the degradation is possible here and the desired pattern wafer is formed here. So this is the type of photoresist, positive photoresist. But in case of negative photoresist, what is done here? So the wafer acts like this, and the photoresist, the part of the photoresist which gets exposure to the radiation remain intact, but the part which is not exposed to the radiation gets soluble. This is the different design, opposite design to this one. So by the so for our desired design, which design we want to design, we can employ positive or negative photoresist. This is the property of negative photoresist, which remains intact after the end of the reaction, which gets not soluble. So depending upon this property, we can classify the positive and negative photoresist, and this is the principle of the photolithography. Okay. Okay. Now, what are the advantage? Why this method gets formed? The advantage of photolithography is it is a versatile method. This is the first thing. The next thing is that it is highly suitable for mass production, that is for huge amount of production. This process is highly used for the fabrication of high density and large array dimension. High density and large array size fabrication, it is useful. Okay, and the process can be used to analyze the neutrophils, which are the important part of our innate immune system, and this could be study the reaction time and diagnostics to make the devices that can detect disease. So it can also be helpful in our medical purpose. Okay, and it should be noted to you that it is extensively used for the IC pattern. IC patterning process. It is useful for the IC patterning process very much. Now the thing that it also contains some disadvantages. What are these? Very expensive because of the cost of the machines. So the thing, it is very much expensive process because of the machines. and the completely cleaned room is necessary for this type of process, because the first step implies a wafer cleaning. So cleanness is very much necessary here, and this is some prototype formation, as because it is the oldest method of preparation of nanomaterials, and the materials used in this technique is not suitable for the biological system because it is unable to uh, stimulate the biological system. Okay, so these are some disadvantages regarding the photolithography. The next thing is that the next stages of preparation was gas phase condensation. Uh, so I will discuss alternatively the top down and bottom up techniques. In the previous section, that is the photolithography technique, I have discussed the top down approach. Now I am going to discuss some oldest bottom up approach, which is known to be the gas phase condensation. Okay, so let me draw a figure out here. Cylindrical shape is not present. Okay, I will manage this. Let me draw the figure so that it will be better to understand what the thing I am going to discuss. Okay, so without writing, the drawing is very much necessary in this process. So by drawing the whole figure, you will understand what the method implies about the basic principle. Now let us point out the things which I have drawn. Okay, and this is tube furnace. Okay, so the basic principle of it is the evaporation of a metallic source in an inert gas atmosphere to form the nanoparticle. This is the main basic principle. So the gas phase condensation is the process which is which employs the bottom up protocol for the producing nano-sized material. This is compatible to precisely control over the process of uh, preparation or parameters to produce the nanostructures with the preferred morphology. Now these synthesis techniques are based on the homogeneous nucleation of the gas phase and subsequent condensation and coagulation. What is the basic working principle here? The suspending the target material into the gas phase, conversion of the target material into the smaller clusters by the furnace, okay, and these enforcing the growth of the clusters to form the nanoparticles by the concentration or coagulation process, and we can collect out the synthesized nanomaterial. So here a tube furnace is used. At first it is vaporizes the it uh, helps in the vaporization process of the substrate, which are then formed as some clusters, smaller components of clusters, and then in these smaller clusters the hot walls uh, helps to employ the coagulation process, which gets coagulated and form the nanoparticles, which then collected out at the end of the furnace. So this process is very much old in the bottom up technique, but it can control over the size and shape of the nanoparticle, desired nanoparticle, very much effectively. Now again it is a continuous process, so both thin films and nano powders can be formed via this method, and this process is ideally suited for the synthesis of the metal nanoparticles, as because the vaporization of metals by the help of carrier gas flow can easily take place, and it ensures the highest purity relative to the liquid phase or solid phase synthesis process, and it can also be used for the large scale production. So these are some certain advantages of the gas phase condensation, but it also have some disadvantages. That is, the process is very much old, and it is indeed very much low slow process. It is very much slow process, okay, and besides, the aggregation of the particle presents a problem in this process. So it can be also possible to aggregate of the clusters to form the bigger particles than the nanoparticles, which is not desirable, and some special arrangement is needed for the collection of the nano powder. So these kind of nanoparticles, for collecting this kind of nanoparticles, some special arrangement is necessary, which is not very much useful, but the application of this process is highly suitable for the preparation of magnetic nanoparticles, and it can also be widely used in the production of ultrafine powder for the use of the catalyzed and optical device, and the use in synthesis of nanoparticles for the gas sensing applications. So these are certain applications of the gas phase condensation. Okay, now the after the discussion of one bottom up technique, let us move on to the top down technique. There is an interesting technique of top-down approach which is known as the ball milling method. It is a kind of top-down approach. Again, we are going to draw a figure to discuss the process. Okay, so it is a horizontal section of the ball mill. Here, basically, some grinding of bulk materials is happening inside the ball mill, and I have drawn a horizontal section of the ball mill to discuss the basic principle of this process of approach. Okay, so along this direction, centrifugal force acts on it. Centrifugal force, and the rotation of the grinding ball is happening along this. So this is known as the rotation of the grinding ball. Rotation of the grinding ball takes place along this direction, and sorry, the movement of the supporting disc taking place along this direction. So as because it is a 2D figure, so it is difficult to understand to some extent, but I uh, try to discuss it by heart and soul treatment. So at first, some bulk materials which can be drawn in freehand like this. These are some bulk materials which gets grinding like a mixer grinder. So it is grinding inside the ball mill like this. Sorry. Uh, like this one. These are the bulk materials. Now while grinding, these gets deformed by these smaller clusters. This gets smaller formed by the way of grinding, like this one. And when it gets small enough to the nano order dimension, we can get out the nanoparticles over here. So this is the way of grinding direction. So the let me focus on this. This is the bulk material. This gets rotated inside the ball mill like this one, and after grinding like this one, it gets some smaller components like this one, sorry, like this. And these, when again grinding, this gets also smaller to the component like this one. Okay, this again grinding, it gets also smaller, but it should be keep in mind, we should have to apply this grinding procedure as soon as the nanomaterials gets formed. So we should have to stop the mechanism. Now the milling rate has to be calculated. How can we measure at after which time we should stop the machine? Is determined by the milling rate, which is proportional to Rm to the power half, I think. So it implies Rm to the power half rho m Rp divided by Rm. Okay. Now what is the capital Rm? Capital Rm is the radius of the mill. This radius is known as the capital R. Sorry, Rm. So radius of the mill, and rho m is the density of the milling media. Either it can be formed by the metal cylinder or it can be formed by the rubber. So the density of the milling media is known as the rho m. Rp is the radius of the particle. Bulk material particle radius is Rp. Rp is the radius of particle, and Rm, small rm, is the radius of the milling media. Radius of milling media. Radius of the milling media. Okay. So this is the all the things we should keep in mind while the discussing the milling rate. Now this process have the advantage that it can produce very fine powder which has the particle size less than 10 micron. This process is suitable for the milling of toxic materials as because it is completely isolated from our environment, so it can be easily uh, produce the toxic nanomaterials which is very much hazardous to our environment, which exposed to our environment, and it is very useful as because it is completely isolated system in which the toxic materials gets formed, and it is also helpful for the production of a large amount of nanoparticles within a very short time. But the milling, the disadvantage is that very large amount of nanoparticles gets formed, it is true, but the milling rate is very slow. It large amount of nanoparticle gets formed, but it takes very long time. And the disadvantage, another disadvantage is that it involves high machine noise level, which provides noise pollution. Okay, but the noise can be controlled when we use some rubber in case of the metallic cylinder. This is a certain kind of disadvantage over the ball milling method. Okay. So my battery is running low, so I am not able to continue this lecture. So the next thing will be discussed in the succeeding lectures.